If you've been here at the last year's conference, we've been talking about HANA Cloud Platform. You've heard it's a platform as a service. You can deploy Java applications up to it. You have UI5 apps and so on. That's great. Supposedly, we're also getting Cloud Foundry now, so everything will be even easier, even better, right? Well, maybe not necessarily, because when it comes to building cloud-native enterprise applications, there are a lot of new things that need to be addressed, a lot of new issues. So in order to talk to us from their experience, we have invited Michael Götzfried and Tudor Rishkutia from our product development team. So at first, Michael will start. So thank you, you have the word.
Yeah, thank you very much, Victor, for the introduction. Also, a very welcome from my side to all of you. It's very nice to see that many faces being interested in those topics. Not just Christian's topics deriving from ABAP, but also the little bit strange ones, but we will come to the conclusion which is a little bit more nice than it seems right at the front. So I'm going to talk today about enterprise applications, microservices, and HANA Cloud Platform. A little bit more detailed, I'm going to talk about challenges for enterprise applications, new requirements associated with enterprise applications, and how microservices and SAP HANA Cloud Platform might give you some opportunity coping with those challenges or meeting the requirements. But first, let me take a short look at enterprise applications. I know for sure that all of you are working with a lot of enterprise applications. That comes with starting to work in a company, so you get enterprise applications. And more, you all do development, so you might extend enterprise applications or even develop whole enterprise applications. But what are enterprise applications? And this is the biggest question which I had when I prepared this talk. So I looked at Gartner, and Gartner says, oh, enterprise application software is like content management, communication, collaboration, CRM, ERP, SCM, Office Suite, project and portfolio management, and so on, and so on, and so on, which means virtually anything is enterprise applications. So this is a good, nice thing. So I'm going to talk about a huge number of applications. I like that. But on the other hand, why is it called enterprise applications? So for one thing, surely you have different requirements if you have just an application on your laptop and not in a data center of a huge global corporation. So they differ, for sure. And the other thing, and we have to understand really that enterprise applications are necessary for the enterprise. The enterprise relies on those applications. And you might have heard some news about some applications crashing, which almost made the whole enterprise crash. So pretty understandable. Management has a very own, very distinct view on enterprise applications. And then I looked to NASA, because NASA has the most sophisticated applications on their way to Mars through outer space. And what they're trying to do, and that's also what management requires us to do, they want to have them managed, and they want to have them even faultlessly managed. And they want to have any fault that comes up repaired so that they can rely on those enterprise applications. So not every one of you or of your operations guys, if somebody is here, might have such a nice room. Some might. But for sure, your management will expect you to really, really, really care about enterprise applications. That's not a joke. I prepared a little one, but it's important for them. So that's just one view, but we are developers. What's the other view? The other view comes, what I told, with a data center view. So we have enterprise applications that are like 20 years old, host applications. We have huge applications like an SAP system in your data center, which has like 8 or 10 application servers, huge database server riding there. And then there's some tiny applications also living there. On the other hand, you might have some enterprise applications which you developed yourself for your company, which you have bought for your company. And even another thing is, there's no change, if you are hosting those applications in another data center. So it's a pretty diverse environment, I have to say. And if you work in a company and get involved in enterprise applications, you do a lot of integration. That's also what Christian used to mention in the last talk. So what does that tell us? So there surely is, with any enterprise application, some kind of evolution. At the beginning, you start with a simple idea. So you like to solve a problem. Then your management kicks in, then several departments kick in, then branch offices kick in, and you pretty much will extend the application. It becomes more powerful, that's the bright side. On the other side, it will become more and more complex. It might become even monolithic, but that's nothing strange. So that happens. That's the course of the time. But then a few years ago, we had some movements in IT which said each and anything has to be mobile. So mobile first paradigm. So anybody was taking its mobile, and what he wanted to do is, if he was in insurance, he wanted to have a policy completely inserted on a mobile device, if it's a wise way to do it or not. But the other question which came up is, if you really have a monolithic application, what are you going to do? So you first, in that respect, have to encapsulate logic, find the right logic, combine the right logic, and tailor it to fit really on a tiny little screen. So this was, and that's what the head is showing, some kind of recycling. So this was the easy part, even if your application is monolithic. But then, and this trend is already not vanishing, but it's spreading, there comes the cloud-first paradigm. And we are right now inside this cloud-first paradigm. But what changes here? You have different requirements. So it's not any longer sufficient if you just take your monolithic application from your data center, because remember, you still have your data center down there. You still have the software down there. It's no use taking that piece of software just in the cloud, do some managed service thing, and just end up having the same monolithic application up there. So what you really want to do is, you really want to identify the necessary business logic. You want to recombine this business logic, and you would extract those business logic and really put it into the cloud to call something really a cloud application, and not a cloud-based application or a cloud-like application, or whatever terms exist for that kind of applications. But you still are on safe grounds. You just want to have one application in the cloud. Now you finally have one application in the cloud. There might just be 2 people using this application, but it's in the cloud. But then the last challenge comes up, and this is really some issue. You want to do it on a global scale. So you no longer have time to do some maintenance cycles of like from Friday to Sunday evening. You're not any longer able to just say, oh, I'll set up another server if the performance goes down. This no longer will be feasible. So what comes up here is a real challenge that might transform what you will do, and that also has a huge impact on the infrastructure that you will need to really be able to fulfill these requirements. So in the next slide, I just combined some challenges, really some, not all. So we've seen we will have some kind of integration challenge. And even if you put your application into the cloud, it's not just integrating cloud and cloud-based applications, but you still will need your applications which really reside on-premise, which you're using in your data center, because they might be mission critical on the one hand, and the other hand, you might not even be able to move that thing into the cloud, but you still want to do a cloud-based infrastructure as a whole. The other thing will be you want to do some collaboration. So now you might say collaboration, nothing new. So we used to include Facebook and we used to do chatting for a huge number of years. So, but this is now integration. It's just living right next to it. You just chat with people, and after you finished your chatting, you even don't know which business object you were working on. But what we are talking right here is that your chat, that your that the interaction is really part of the business object. To give you a short example, when you are in insurance and you're handling a claim, that you will talk to a lot of people. And each statement from each colleague that you're asking, internally or externally, has to be stored, that after the claim handling has been finished, that you can review it. Even if somebody sues you, that you can prove it, that you did everything right, that you looked in all aspects of the claim and handled it. So what I'm talking here about is really combining business object, and the other thing is the chat, closely together. Next thing is extensibility and change. Nobody will believe you if you say you build an application, it has every requirement fulfilled that exists on Earth, it will never have to be changed or to be extended. Such applications don't exist because the world keeps on turning and your views on applications will change. So what you're expecting in that area is that you can have new requirements implemented, that you can have change, that you can have corrections applied to your software without losing the most important property of this software. The software should still be standard software. So as a lot of people here are ABAP guys, they will say, oh, that's not an issue. We know how to handle that. But the biggest problem which is mentioned here is if you more and more change an application, it becomes harder and harder to apply any change. It becomes harder and harder really to do additional requirements with this software. And the other thing, you always will have a huge mess when you think about maintenance, when you think about applying patches. So when you think about going to the cloud, you no longer want to have like 2 weeks of SPADD, SPAU, whatever stuff that you're doing, talking to a lot of guys, but you have to have the possibility to just apply a patch and then keep the application running. Which brings me to the next property, to the next requirement, is performance and elasticity. And if you look here, and you're coming from the ABAP world, you will say, oh, this is not an issue. Take another application server, make a more powerful database, put it in another HANA box, go to HANA. But what I'm underlined here is dynamically. So I don't know how your purchasing process is in your company, but it might take some time until your application server might really arrive in your data center and being set up. Or if you say you're in a managed environment, then you even have to have somebody giving you the credit card and ordering stuff. And so it's a little bit timely. What I'm talking about here is that you don't have to care about its scales. It really provides you with the elasticity that you might expect. So a nice example in that area is you build a little application just for one user. At the end of the week, it's 50,000 users. What are you going to do? Buy hardware for 50,000 users is not a valid solution unless you have a real good relationship with your management. And the last thing is operations. I know that you might probably not like operations a lot. So if you're on the development side, operations guys are a little bit strange. They want to keep the application running. And that's just what is the challenge here. You're saying you want to deploy several versions of your applications in parallel, keep them running. You don't want to have several application servers hosting those versions. So the question is, how do you do that? Maybe a nice question to ask, how do you do that in ABAP? Might be difficult. The other thing is you might want to do some patch and monitoring process. And on the other hand, you might have the challenge to reduce costs greatly. and management bugs you to implement some DevOps approaches. So getting closer to the development, being able to just support the people who do the software with the operations part of the software lifecycle. So all in all, this is some kind of an n-dimensional challenge, as I call it. So it's not just SAP, for sure. Your usual data center is filled with different technology. On the other hand, we learned a lot because we now know that an integration on the technical side is not possible in such an environment. You want to go to a business-driven integration, which you are using. And the other thing is, technology agnostic interfaces are there. So we have web services, we have Corba, so quite nice environment in that area. But we'll come back to that in a few moments. And the other dimension that I want to highlight is the dimension of cloud, of on-premise application and hybrid applications. Because we have clearly one statement that we have to keep in mind: some applications may stay on-premise forever, or at least until they are decommissioned. So they won't make it into the cloud, so in the end, we have to cope with them living on the data center. I had a little nicer word for it. I called them mission-critical applications because they couldn't be replaced and they should stay on-premise. And the other thing is, most of the time today, we're talking about just having one application in the cloud, or on the other hand, having it on-premise. But this is also something that might change in the future, because it also is possible that you have part of your business process really residing on-premise, because it's not yet in the cloud, and other business processes already being in the cloud, and so realizing a hybrid scenario. Also a hybrid scenario for the reason that we might have some application like an S4 HANA system on the one hand, and on the other hand, an extension to the system on HANA Cloud Platform. Last buzzword for today, and I guess it was also the first one, no, I mentioned cloud, is digital transformation. I called it innovate, be fast, differentiate, because that's what you want to really do. You want to be innovative, you want to be faster than your competitor, you want to get that out to the public. And so the challenge which comes with that is that you really have to imagine your application. You start developing, for instance, like Christian showed us, and just develop an application, prototype it, then you build it, and you pretty soon are going live. Sounds very easy, but if you think about the life cycles which we had in the last years, they were pretty long. So you needed like 1 year to get out, and this is a little bit too long. So in that instance, cloud is no longer a buzzword. Cloud is just an enabler. Cloud is a runtime environment for this. Cloud provides you with the flexibility when it comes to development environment. But it's also something else which you need, a little bit more flexibility in your organization. So implementing, for instance, DevOps approaches, where you bring together the people that you need for being able to just deploy an application this rapidly and bring it to your customer, for instance. The other thing, like scalability, we already mentioned. So you pretty much don't know how your application will behave, so better prepare it to be able to scale anyway if you go to the cloud. Integration of big data and of analytical scenarios is something that is very, very necessary, because most of the applications need more intelligence for what they're doing. But on the other hand, nothing can be gained without the last property, the mobility and the networks, because still, if you think about Switzerland, Switzerland has a lot of high mountains. And if you do a mobile application and travel through those high mountains and don't get connectivity, you still will be lost, which means you might also consider still offline scenarios. Might not live forever, but might still be necessary today. So with all of that, we have talked a lot about challenges, but you might ask now, where are the solutions? Because I was saying I got solutions with me. And this is right, but the biggest issue is I do not have one solution. So if you expect me to say just use microservices and it's not anymore any problem, you can do anything, I can't do that. Because quite frankly, if you looked at the problems that I presented, there are several solutions, even conventional solutions for solving that kind of problems. So it's still up to you, it's still up to the developer to just find out which solution is good for solving that kind of a problem. But another thing is really correct. Working with this kind of technology, it will become an interesting journey. Not interesting in the sense of you never arrive at any destination, but interesting because of the problems that you have to tackle. So let's go a little bit to the microservice world. The question also comes up here. Microservices are very popular right now, might be some buzzword also. So the question comes up, is it really the next big thing, or is it really just the next big zoo? And as you see, those little microbots, they look not the same, but they are the same kind. They do nearly the same work. And that might be a good example for the microservice world. You have a very diverse set of libraries, a very diverse set of architectural approaches that could be used to just implement one microservice, but still you have to find out for yourself which of those approaches is good for you and which approach that you want to use for building a microservice. As always, when you think about a new technology, it's always good to have some kind of definition. This was also a very interesting journey because you have a lot of definitions. So I thought, why not just look at the properties and the requirements of such a microservice and just some of them and discuss it with you, because that might help you just to understand and get a hold on what and why we are doing that kind of thing. On the one side, microservice is just a little bit about modularization, because underneath microservices you have a modeling concept called domain-driven design, which makes you divide your larger software in smaller and easier to handle parts. But on the other hand, this also has one impact on your organization, because you say this part of the software is just handled by this team, but it's also maintained by this team. It's not just developed by this team. So you give a lot of responsibility to just one team. You also have the situation that you not only say, this team handles this part of the software, but you also say the teams handle it independently of each other. So this has a huge impact on your organization. And this also has a huge impact on the trust of your management. So compared with that thing, separate deployment may seem a little bit easier. But this is just what's involved with it. You just develop one microservice in one team. You don't ask the other team. You just deploy it because you're ready. You're done. So that term done becomes a little bit more relevant than it's right now in Scrum environment. So when it's done, it can be deployed, given the infrastructure does allow that. Technology agnostic, and this is also connected with the organizational aspect. You don't care how the microservice is implemented. It could be in Java, it could be in programming language X, Y, Z, could even be done in ABAP. So it's up to the team what they use. It's also up to the team what they use as persistence. In practice, I guess, you will have one or two people looking over that kind of zoo which would be developed. And on the other hand, you also have the teams who experience that being responsible for something also carries some thinking in advance with it. So won't be too bad, I guess, in the future. You want to develop something loosely coupled. Well, we've done that in SOA already. And you also want to develop something really resilient. So resilience is very, very important, because what you're really doing is you're developing a distributed system, and you don't want to just have one service failing, bringing down your whole system, which you have done. But on the other hand, and this is also very, very important, microservice is not something like in SOA, which cares about the whole company, which tries to model the whole company up front. It just cares about the system. So each microservice just knows its environment, and the system is the border of the thinking in that kind of area. When it comes to communication, it's mostly REST, or it's messaging between those applications. And the most strangest thing for ABAP developers, I guess, microservice can have its own storage, its own DB schema. Because a few years ago, we were proud to say if we have one SAP application, it resides on one database, which is very, very important for that area. And the other thing is we care about UI. SOA didn't care about UI too much. So we even care so much about UI that we integrate bits and pieces of a UI, fragments, as some part of a microservice, or we even develop one whole UI and associate it to the microservice. This is a distinct advantage for if you think you add an additional field to that kind of microservice, it might pop up on the screen. But one little thing is also clear: there's no standard way of describing how that is being done. So even if you succeed doing such a thing, it's your theory, but there's no standard solution for that kind of UI integration up to now. But let's stop with this very theoretically part, and I'm going to hand over to Tudor, which will explain you in a little bit more detail about the architecture.
Okay, thank you, Michael. So, too loud. It's better? Okay. Again, welcome from my side. I'm a product owner, let's say, or a developer at MSG. I work in the product development department. Definitely not in the market, because I chose this picture. And what I would like to answer is really how does microservice really look like? And for us, and here is a bit of a disclaimer, all I'm about to tell you is based on our experience working with microservices. There is no standard way to do this. It's our recommendation. For us it worked, and we came up with this onion. Why this onion? If you cut it, it can make you cry, yes, that's for sure. But if you cut it, you get to this stuff, which is called the onion architecture. And I would like to ask a question. If you could raise your hand, who here heard about this kind of onion architecture? Or maybe hexagonal architecture is also a term. I see a couple of hands. That's very good. Then I can tell you anything because you... Yeah, why does it look like an onion? And this is really different than what we know with the traditional ABAP stack, with the persistence, business logic, and application. It's really different, and this is because of the microservice. In the center of the onion, we have our domain model. This thing is called also domain-driven design. We have this book, it's really good, I recommend it. So what we try to do with a microservice, because it's small, we no longer try to create a data model for the whole enterprise. I think we've tried this in the past, especially with ERP systems, but this doesn't work. And just as an example, in ERP you have something like a material or a product, and this means something completely different for different parts of the ERP. For example, for someone in production, material is a lot of stuff, how it's built, how it's made. For someone in sales, it's just a number. For someone in inventory, it's a size, how big it is. But we no longer try to do this. What we try to do is really wrap microservices around functionalities or modules. And in this case, let's say we have a microservice for production. And here in our small domain, we really have everything that the business needs for this production microservice. We have here no specific technology. It's not about the development, the programming language, but really about frameworks and all that stuff. We have no database here. We have no UI. We have just the pure business logic. And it's all made up of, let's say, some classes in object-oriented programming. And they really resemble what the business does. This is really important. This is where we start. And we do it together with our business consultants. We have a large team. Around this domain model, we have what we call domain services. Here we are still in the programming stuff, in the business logic, and domain services are just some kind of APIs. And the advantage of having such a thin layer, we don't have any business logic here, we just call the entities, the domain. And the advantage is that we can really test this stuff without any database. It doesn't matter. Here we just do the programming. This is where we start in product development. And here we really make sure that the business works and the software does what it's supposed to do. Around this thin layer, we have what we call the application. The application is really a set of adapters because our microservice runs in a solution. And we have here maybe some web interfaces like REST or OData or whatever the service needs to run. And we also have here, if our microservice saves some data, we have some repositories or really anything that the service needs to run. And this application is really the deployable unit. So this is something that we wrap, we finish, it's done. We can take it and install it somewhere in the cloud, or microservices, you'll see they work on premise, they work really anywhere. And in the future with Cloud Foundry on SAP HANA Platform, you can really do, the possibilities are endless. And we have another layer, which is made out of two. And here we have the user interface. This is an optional layer. Not all microservices have user interfaces. Sometimes we have just some complex calculations wrapped around. And we also have, very important, the infrastructure. And the infrastructure is really all the microservice needs. We have here databases, logging. Maybe you want to send emails. We have an email server here. It's all out of part of the infrastructure. And with SAP and HANA Cloud Platform, all of this stuff comes in really, really handy. So when we started with this, we had something else. Then we got to the Onion, and the Onion worked for us. And we recommend this kind of architecture. But one of the first really questions was, how big is the onion? And we started with a lot of small onions that wrapped one functionality that didn't work out. We lost a lot of stuff. It's really important to know that all microservices communicate over the network. And if you don't have a fast network, then this is an issue. Then we had some kind of limits like lines of code. How big is it? 100 lines of code, 200 lines of code. This doesn't work out, especially if you use some kind of complex frameworks, because they take a lot away. And then we got to the term or the decision that the answer is, it depends. It can be as big as it must be, and it just big enough to do what it's supposed to do. And here we have another topic, especially in the world of microservices. If the microservice is too small, it's called a nanoservice. And there are some nanoservices which make sense. For example, in the ERP world, we can have, let's say, a currency conversion as a nanoservice. And that makes sense because that's reusable, you call it a lot. But if you have something that you don't reuse, it's just there, you call it over the network, it's bad. And we call that an anti-pattern. Because the development time, the effort we spend building it, it's not worth it based on the functionality. So the answer is still, it depends. We have now some bigger microservices. We've built one solution. Unfortunately, I'm not allowed to tell you about it. It's still a prototype. But we have a huge process, something with accounting, and I can tell you we have something like 6 microservices in total. And they were built by 2 teams, and they were built really with the, every time something was done, it was deployed, it worked. We didn't have to wait. We also came from ABAP background. The daily release, the Monday, Tuesday, I think all the ABAP developers know. We don't have that anymore with the microservice approach. So how do they work in action? My colleague Mikhail will tell you about it.
That's a very nice thing that Tudor says. We really did what we are talking about here. But the thing is, we talked a lot about theory. So another question is, what are the scenarios really for those kind of microservices? So microservices in action here, we identified like 4 different scenarios where we would like to use it. A very, very intuitive scenario is a mobile app. We will see that also in the hands-on session. We prepared something with the help of Johannes and Tudor in that area. Because in the mobile application, as I said also before, you do not want to have like 4,000 attributes being in one interface call. You just want to have those attributes that you really need. And this is really something that is very, very nicely being done with using of microservices. The other thing is, and this closes the gap between this strange topic which we are presenting and the topic from Christian, HCP pretty much, and also the use of microservice is the strategy for extending S/4HANA. S/4HANA on-premise, S/4HANA in the public cloud, because you do not want to do a lot of body implementation in there uncontrolled. But if you have a new functionality, you want to build it and build it right next to it, and Christian likes that approach, as I see. The other thing is microservice is also a means of integration or an integration technology. Not too much of a technology, but it is a different approach to integration. Because what we used to have in the last years with SOA, we had a lot of enterprise service bus, a lot of enterprise application integration, and this is no longer so much the case in the microservice area, because we say that each microservice does its integration itself, so you have a nice interface, very business-like, defined and implemented, and you just use it, and you don't use too much of enterprise service buses or other stuff, which doesn't say that you do not use them at all, but you not as much use them. And the last thing, and this is the most interesting part in my view, is building applications using microservices. And that's a thing where we will think on in the next slides, but we had one information from Tudor which was very, very important. Microservice doesn't always mean micro. So if you build a whole application, it's not about 6,000 microservices, so they might differ in sizes, and then they might make up a little application which is really nice. So did we do a mistake? Because in the last years, we thought about SOA, and I guess a lot of you implemented like SOA services, web services, thought about enterprise services, did a lot of modeling. So did we do a mistake? So SOA is an approach which finds a solution for the enterprise, for several enterprises, does a lot of governance. So was this wrong? No, it wasn't. Were the artifacts useless? No, they weren't. If we have developed nice business objects, if we have developed nice interfaces, we could reuse this information, also take it to the microservice domain, but just go a little bit smaller. The other question is, SOA didn't care too much about the individual service consumer. We always picked out a few consumers and built one service which would fit all of them. This was one paradigm which was very, very fast stopped, because when the world of nice user interfaces came up and the world of mobile user interfaces arrived, you pretty much understood that you wanted to have the right interface for your application. So you might end up having like 3 or 4 versions of one similar business functionality, which was not the way SOA would like to have that. So on the other hand, what's the microservice world? The microservice world focuses on this UI, focuses on the distributed system, doesn't care too much about the enterprise, but still takes the information which you have generated in the enterprise and puts them in this business service. We also have the goal to provide something which is scalable. Scalability is something which also depends on the infrastructure that you have. And if you have a Cloud Foundry-like infrastructure and if you have a microservice-like approach, then you might achieve good scalability. The thing with ERE and ESB we already mentioned, so that doesn't care too much in the microservice world, but on the other hand, it changes a lot the development organization. We will elaborate on that in a few moments, but I can say here that you just will integrate different people in your development team. You just have to become one team which can handle one business domain, one microservice, because you not only design them, you bring them to the customer, you maintain them, you test them, you do user experience considerations, and you have to have people for that on your team. So in the end, can we do this approach? Can we go this way? And in my view, we can start going that way because all of the concepts we heard, they are not new. Distributed systems are not new. There are a lot of architectural literature. There are a lot of people doing microservices. SAP is doing microservices. So it's something really worthwhile considering. And looking in this neatly cleaned up workshop brings us maybe to the toolbox that we could use for developing such microservices. What I brought with me is some depiction of HANA Cloud Platform. And when it comes to microservices, it's really important that the platform itself offers you a rich tool set. And as you can see here, the tool set ranges from UX over mobile to very important topics like security or integration. But on the other hand, what you still do not have to forget, you also have some business services which are also part of this platform. And this is also one very, very important aspect when evaluating such a platform. Do I have services which I could reuse? Because I do not want to do all of those services myself. So if you think about billing, it's a nightmare doing billing because you have to have MasterCard, Visa, all those processes, Swift, whatever, implemented. You do not want to do that. You just want to reuse it. And as you can see, you can reuse it in that infrastructure. What you also will need, and that's what your developers will ask of you because they want to have fun, different development environments. You want to do Java, JavaScript, HTML5, maybe something different. We decided for us, we do Java, a little bit of JavaScript, so we mix it. But as I said before, that is not important. What's important is implementing the concept, and what's also important is giving the team the information they have to maintain it. So we have something diverse. Then we also see that it's very important on that platform to have development and operations being brought together. And if you think back to a slide before, that's also the case for the DevOps approach, which we had as some kind of requirement. And it's also necessary if you really think about deploying something tomorrow, which you started like 2 weeks before. Then you need a lot of people together working to this state of deployment. And that infrastructure supports you with the tooling which you might need. I'm not going to talk too much about the persistence part. You can see a lot of databases, also very nice, because I said you might have one database per service, so have your choice of weapons. And on the other hand, you clearly see that HANA Cloud Platform is positioned between those on-premise or managed applications and real public cloud applications or software as a service applications, and offers a lot of integration capability and management capability for that kind of approach. So for the business guys, for the management, what's the benefit? Because I was at the customer side talking to them about such an approach, telling them it's nice technology, I like it, we should do that, but the only thing that they were interested in is how much does it cost? So cost savings is a big argument if you can bring something for that. But the other hand was, and it was very astonishingly, we heard that we have a strategic dimension to that. So they understood that it's a new approach, changes the organization, enables them to do digital transformation. So this was also quite nice because it provides some leverage which is not associated directly with money, which is always hard to prove. And the other thing, but that doesn't interest management too much, you bring the capabilities for solving the problem because they take that for given. So if you present an approach, they will believe you that you can do it. So reduce operation expenses, what you could say is that you do not have to have like 20, 30 or 40 servers just resting and idling around. You just use your infrastructure as you need it. If you need more infrastructure, you can do cloning of services, which also reduces the management cost. And the other thing is you do not do any peak load sizing, which means when you have a normal system, normal SAP system, you do some sizing, and you also take into account that once or twice or 3 times a year, there's one performance peak which must be handled. So in that kind of setup which we have here, you just try to get what you need, and if you get more, there's more potential to really being given to you by the infrastructure. On the other hand, this is also part of the flexibility which you need. So it's not about ordering your hardware now and waiting for it like 6 months. It's like having an infrastructure which enables you to use it for testing, to use it for real world deployment. And on the other hand, an environment which is so agile that it does react to performance demands dynamically. That's something that we said before. And not to forget, something which is pretty much high available, which is something that you would have to do in your own data center for a lot of money. So we heard a lot of microservices right now in the talk. So is it going to be that nightmare? So 200 microservices riding on your servers and not being managed by anyone. So the question might come up, how do I build an enterprise application out of that? Yeah, first thing I would recommend is manage that kind of resources which you have. So get API management in place. That's also what Christian managed in his talk. So this API management gives you the capability to manage deployment, to incorporate billing. So to have one service up in the cloud, which you can really ask the customer for money. The monitoring part, traffic management, and on the other hand, also a very important part, the versioning. So if you think about enterprise applications and microservices, in the literature you have like 2 approaches. A very strict approach, that's the first approach anybody envisions. That's also the first approach that the development team tried to realize. So do strict domain-driven design, no deviations whatsoever, follow it perfectly. They pretty much and pretty soon found out that wouldn't work too good. But on the other hand, it's a good starting point. The other thing is no integration servers. Yeah, well, that's a big thing to say. Let's see if we really can work with it over time. And the other thing, one microservice, one database, this was something that very, very easily came off the shelf because we had SAP HANA. We want to leverage HANA capabilities. We want to do some reporting on SAP HANA. And this pretty soon ended the approach of having like 20, 30, or 40 databases, which we use for getting the data for our reports. We didn't like that too much, and it wasn't a wise decision. Right sizing of microservices, that's what Tudor already explained. This is something very easily said, but very difficult to achieve. And pretty soon you come to the conclusion that an integration server might not be a too bad idea to have it, even if you think about messaging. You like a message queuing system, which handles a lot for you. You do not want to do stuff without it. Reality-driven, domain-driven design means that you really think about the rules which are in domain-driven design, but confront them with your requirements from real world, and then say that maybe a solution which is not textbook-like might still do the job because it's well thought through and it's well tested. And last but not least, use SAP HANA because it's a very powerful system which we liked a lot, and so we deviated from our strict approach pretty much. So all in all, when it comes to development, you have some challenges, and basic ones are pretty easily to understand. Please care about security, and please start about caring very, very soon, right at the beginning. Think about logging, because if you have a lot of services in your environment, you really want to find out when something happens, why did it happen, where did it come from? And this is a more difficult question to answer than you might think, because if you have like 5 or 6 services, you have to somehow establish a kind of relationship between those services. And the other thing, you most of the time need some kind of hexagonal architecture, so you need several interfaces into play, combined with a business logic. You do not want to re-implement your business logic several times just because you exchanged your interface type. But the good news was the advanced topics, which included circuit breaker, which means if too many requests come to your microservice, the microservice will stop working without destroying the whole system, or throttling, which means limiting the number of requests which are accepted, which is a little bit different or a conservative approach. Same as retrying billing or management. This is something that you can handle with API management. And this was the reason why I said this is the first thing to think about, really, and to establish that kind of API management. So from the integration side, we have in the center the HANA Cloud Platform. And what we most of the time still do is we connect to the private cloud, we connect to the data centers, because as we said in the beginning, some applications will stay in the company or will stay in a managed environment. On the other hand, we will surely use HANA Cloud Platform to extend X4HANA, which is still on-premise maybe, but also connect to S4HANA systems, which are part of public cloud. And this is also very, very important, because in public cloud, you do not have the chance to really work with the code a lot. You do not have the possibility to implement a lot of business functionality which you'd like to introduce. So you need a different environment, and this is SAP HANA Cloud Platform to implement this kind of business logic. And on the other hand, as it's drawn on the left corner, you have to connect to your UIs, to your mobile devices. And please excuse me, this phone is not really a smartphone, so it's just an old-fashioned one. But what I meant is smart. The other thing is really care about identity management. And I don't want to go into too much detail of identity management. I just want to highlight one thing. you don't just have one microservice, you will have several microservices, which means on the one hand, you do not want anybody caring about security individually for each microservice. That's number one. And the number two is think about grouping stuff and think about introducing groups in your tokens, because that way enables you to simplify maybe the dilemma of managing those security or identity management. So when it comes to persistence, we still have a lot of freedom. We used Java Persistence API, we used Java Database Connectivity. This is just from the Java world. We could have taken another example to access, on the one hand, HANA databases, different databases, but also to access SQL script on SAP HANA. But one thing is also very important. If you expose like a CDS view on your HANA, you might still call that a short form of like a microservice for reading information. This is something that proved very valuable, because otherwise you would have to wrap that kind of stuff with a lot of Java, and that was not something that we would like to do. But now we are at the stage of bringing it all together, and I'm going to hand over to Tudor again, that will show you some examples that we did.
Okay, I told you before, we built a prototype, but we are not allowed to show you, but we wanted to show something. So my colleagues and I, we built one demo application. We call it MSG Event Management. Maybe you saw it on the invitation. There is also one poster over there, and if you have questions about it, please ask my colleagues. They will be in the other room in the break. So and this, what we try to do is build an application to manage events. It would have been nice if we could say that we managed this event with it, but we weren't that fast to build it. But we wrapped around some key capabilities. We want to see some upcoming events. We have a nice planning calendar. We can organize an event. We have a timeline, some to-do lists. We can also add attachments, contacts. And what we wanted to show is really with UI5, how can you do this promotion? And we use collaboration. That's what my colleague told you about. And we use SAP Gem. SAP Gem is a collaboration platform from SAP that runs on HANA Cloud Platform. We also can send emails and do some social media. This was a bit overkill, but we wanted that the application looks nice. And I will show you a demo of it, but okay. I prepared a video, so we know it works. But you can ask my colleagues, and you can see it in the other room during the break. So this would be the first screen. We want to browse. We have here, we have here some kind of carousel with some upcoming events. We have here the planning calendar and in the bottom. I registered myself, but I'm really fast, and that's why I have to break from time to time. So here you can see the IT conference, which is today, and also the hands-on tomorrow for the ones which are participating. We also have some kind of advanced search, but it's not really important. And apparently I wasn't that fast. And now this is how one event would look. We have here on the side a Gem integration with some comments and shares. I didn't open, but we also have a Gem platform where you can see all this stuff. We have some text editor to write some text. Okay. Super. Then we have really the tasks. In this case, we are lucky. We only had 2 tasks to do for this conference, and they are both done. That's why the Harvey ball is green. So everything went well. We had a small delay, but forget about it. We have the Gem integration. We can post some comments which are public on the Gem. We have some groups of users who can see them. We have some attachments here, and this is really the documents that we save here are stored in the cloud. HANA Cloud Platform comes with a document service to store unstructured data. This is out of the box. We uploaded some files here, and we also have some contacts, like our marketing department, somewhere in the room. It's not a real information except the email. Doesn't work, you see. Not the real stuff. And one last thing about social media, we have some Facebook share, and it's some link, but you get a picture how it works. This is the demo application, how we built it. If you have any questions, in the networking break in the other room, you can find out more about it. And what I wanted to say that is really, this is a microservice-based application. Just looking at the UI, you don't know that there is more than one microservice running. I could have built this in ABAP. I didn't show you any coding, so it could have worked either way. But what we did is really use the HANA Cloud Platform to do it. We wanted that the application runs only in the cloud, so we have nothing in the backend. What we do have is Java. We had to do it in Java. Currently, this is the recommendation from SAP for the cloud. We have HTML5, that's the nice UI5 application. And we also use some of the platform services which come out of the box, like the collaboration, that was SAP Gem, or some security to log in. And we also used the HANA database on the cloud. So this would be one demo application. And the question here with microservice, we told you about, you can implement them in any technology because they communicate over the web. But the trick is to really find the right technology. And to find the right technology, so far in the HANA Cloud Platform, we are limited to these runtimes, but later on I expect that there will be more and more, ABAP and other languages. It's just a decision. And what comes next after this decision, it's really how the team changes. And in this case, this is how our team looks like. We have a domain expert. This is the business consultant. And what we've seen with this is really how the organization changes. And this is what my colleagues already told you about. The organization changes. And I think you know, or you already have departments, or in your company, I used to have it. We also have it like Java teams, ABAP teams, SAP Basis, one group of business consultants who only understand themselves and all that. But now with the microservice approach, this really changes. And now we really have teams which are combined. So you can see here we have a tester, which is part of the team. If we have a UI, we have a UX designer, a system admin is really important. Some sharp database expert, the domain expert is in the middle. He drives the business, and the developer, obviously. And to picture such a team, there is no definition. Again, you just put in the people that you need. And but what we found is that you can have some characteristics for a team, and we identified 4 of them. This is a real example. We have self-sufficient teams. What this means is that really the team can work by itself independently. We have no need. We don't have to call some SAP Basis guy who is lazy and has to do some stuff, and we have to wait for him. The guy is in the team. He's together with us, and we are doing the stuff. We have all that in the self-sufficient. What comes with self-sufficient is really multidisciplinary. So we have all the knowledge. We have the business consultant. We have the developers. If you are doing Java, we have Java developers. We have ABAP developers. We have some multi-language developers. We have database. We have everything. And what is really important and what really changed now is this autonomous part, which is new. We now let the teams make the decisions. So if we have to build a new microservice, the business expert says we have to do this process. And then we as a team, we make the decision, what do we want to do it in? And with the HANA Cloud Platform, we now have options. And we usually say Java or ABAP, but we have other options. We have the possibility to select the database. We have HANA, we have NoSQL. It really depends on what we need. So we are autonomous, and management trusts us to do it, yeah, I hope. And what comes with this autonomous is this DevOps approach. And what this means is you build it, you maintain it. So it's no longer that we build a service, we transport it, and good luck to some unlucky fellow to maintain it. we have to maintain it. So if we choose Java, then we have to solve all the issues that come with Java. If we do ABAP, we have to figure out how to make it work with ABAP. So these were some characteristics which are really needed, and if you want to give it a try and really do microservices, you should have all these four. Otherwise, it won't work. If you wait for decisions from management, if you wait for administrators, for admins, for testers, and so on, it won't work. We really have this, and it really works. So this would be the characteristic of the team. And here is a wrap-up from my colleague, because we are kind of perfect in time.
We nearly made it. So, last slide, bringing it all together. I do not want to tell you too much about this thing, because Johannes is already warming up for the last talk of the day, and we will be doing a lot of that tomorrow. So those of you who enrolled in the hands-ons, you will do that perfectly from A to Z. But what's really important, and that's why we chose this slide and this scenario, it brings really together everything. So we are no strange approach to anything again. So we develop our microservices on SAP HANA Cloud Platform, expose it as services with a OData interface. We use this kind of technology also on the back-end side. We have the S4 HANA system, and we use NetWeaver Gateway to just also expose some services developed in ABAP. And now this is the reconciliation. It brings us back together again. So we have Java on the bad side and ABAP on the good side, and all of that things working together in a real nice scenario, bringing real business value to your mobile devices. And yes, this is no smartphone, I know it. I have been bugged a lot by my colleagues about showing it to you. And this brings me to just the last thing, saying thank you to all of you for your attention, and we will be grateful to accept your questions if you have one.
Questions, please. Otherwise, I will start with the questions. No, I was curious about one of the last things you mentioned. Did you about reshaping the team? Was it for you something like the same team acquiring new roles, or bringing in new roles from the outside?
I think it was both. Initially, we didn't think about bringing in all of the guys, because we just established a team which became self-sufficient, which learned a lot of those technologies, which had fun learning those technologies and worked on it. So they became self-sufficient. But on the other hand, what we really did is, in our organization, we talked to the operations guys. So we made them aware that something is going to change, that they have to really cooperate with us more than they did in the past. And we are in a very, very privileged situations, because they already did a lot with us together with development. But problem was more bringing in the flexibility, the agility, because they had a lot of tasks to be handled. And then a crazy team came and did a lot of work, demanded a lot of attention, so this was something they had to tackle with.
Yeah, we were already working with a Scrum-like approach, or we think we do. So we already had some of the disciplines, like testers and business experts. They were part of the team already, so it wasn't such a big change.
You can say the name of your team, maybe, for the crowd.
Yeah, the name of the team in Cluj. We have 5 teams in total in our branch, but only one team in Cluj. It's called Team Ursus. If you are curious about it, you have to find me later around here, and I can tell you the story.
Okay, any other questions?
Okay, so I have 2 questions. First, for this size that you said, I guess there will be scenarios in which you realize that a microservice is too small or too big when it is running already or when it is deployed already. Do you think that it's possible to merge or to split microservices in a useful way, or you have to really redesign them completely?
The answer is, again, it depends. That was the initial answer. the size of the microservice is really with the business. It comes together. If the business allows it, you can split it, and it works. But with all these web APIs, the consumers, they don't care. So you can take one microservice and implement a new one in completely something else, put it there, and nobody will notice. That's the magic behind.
Okay, so you don't fear then that it will be deformed in a way if you merge it and it's some kind of mutant in the end?
It will be a mutant in the end because it's an enterprise application, but we are not scared about it because the team manages it, and we don't have really a huge API for a bunch of services. We have small APIs, and we have teams that collaborate. And you have one team that does one task A and one team that does task B, and they need some from the other. They talk together. We have what is called a contract, where one team has to build an API for the other guys to work. So we know all these dependencies. That's how they work.
And then when you do the design, you could start big and become smaller. But the tricky part is you could also start small and become bigger. But the nice thing is you can have your enterprise service, which wasn't right for your requirement, still running. Because this is also part of what we have here. You can't switch it off because somebody might use it. And what would you do then? So you have to have a transition. And so it's also the same word, it depends.
Okay. So then for my second question, for these self-sufficient or independent teams, isn't it a problem in the end that if you lose one member, it will be somehow this self-sufficient or independent will be lost in the end and it will take time for you to replace it? Or how do you mitigate this? Because you said that each team implements microservice as they want. So you might have a team that always uses Java and a team that always uses JavaScript. And you cannot switch people between them in the end.
Yeah, that's in theory. In reality, we have this guy here who says which one to choose. We make the decision together, but it's...
there were some codes there. Each team that decides then.
No. We are agile. So at the end, the guy who decides is still some part of the team or very close to the team, and we really talk to each other. And that guy that stands next to the team has one problem. He has to convince the team. So they have to like what the other one says. They have to really support his ideas. So on the one hand, he has to be very convincing, because otherwise the team wouldn't like it. And on the other hand, somebody like an architect would like the team to make decisions. Because we're doing so many services when we really build an application that you can't really have someone controlling each and every step, each and every line of code. So you want to have power to the team, and that is the part which is very bad for management, bad for the architect. He has to accept that the team says, no, we're going to do it completely different. But the architect has always one little saying, you can do whatever you want, but you maintain it.
Yeah, so to answer your question, we are new to this stuff. So we haven't lost any member of the team yet. So maybe next year I can answer this question. Yeah, that's still the problem. We are autonomous, but replacing people and stuff like that, it's still up to the management. They have to earn their money and do some work at the end of the day.
But people learn because they cooperate closely with each other. So knowledge gets spread.
So I guess this comes with maturity in the end.
Yes, and we said we learn some of the stuff, so we don't have really fixed roles, like you're a tester, you're a developer. We do a sort of a combination. The decisions are taken within the team, and this works out really well. Depends on the team members, but we have a nice team, and you can meet them in the break.
Okay, thanks.
Thanks.
Okay. Thank you then. Thank you, Tudor. Thank you, Mihail.